Hello everyone, and welcome to another math tutorial. In this next video in our series on matrices, we're going to talk about the inverse of a matrix. I'm going to show you how to find the inverse of a 2x2 matrix with and without technology. And then I'm also going to go over just how to do a variety of different operations with the graphing calculators that you're probably familiar with. Let's jump right into what the inverse of a matrix is. All right, first I want to go over some key features concerning the inverse of a matrix. Okay, so let's read through these key features about the inverse of a matrix. First, just like when we talked about determinants, only square matrices can have an inverse. I say can have an inverse because not all square matrices are going to have an inverse. And we're going to see some examples. We'll discuss when matrices don't have inverses. The final thing is that the notation that you're going to see for the inverse of a matrix, so if we're dealing with, say, matrix A, you're going to see A raised to the -1 power. This -1 power is not indicating that you do your negative exponent power property that you're familiar with from algebra before, but it just indicates that we want the inverse of the matrix. Now I want to go over a formula for how to find the inverse of a 2x2 matrix. Okay, our formula for the inverse of a 2x2 matrix is going to be this right here. So I'm just using A, B, C, and D as my entries. Of course, those are going to be numbers later on. Our inverse formula, we're going to take first 1 divided by the determinant. And then if you look at the way the numbers are arranged, or the letters in this case, are arranged inside the matrix, the numbers that are on this main diagonal right here, which are the A and the D, notice how they compare to the original over here, and you can see that those two numbers have just switched places. And then if you look at the numbers that are on this diagonal, the B and the C, and compare them to how they look over here, those two numbers have just switched signs. So if they're positive, they will become negative in the inverse, and if they were negative in the original, they will become positive over here. Now, I said earlier that not all square matrices are going to have inverses. So let's talk about which ones don't. Right here, if the determinant of your original matrix over here is equal to 0, then the matrix is not going to have an inverse. And that should make sense because we've got the determinant of the matrix on the denominator of the fraction. You're not allowed to divide by 0. So if that number right there is 0, then you can't do any of this inverse formula right here. Now, if the matrix has no inverse, a little bit of vocabulary here, we call that a singular matrix. Okay, that's enough for this slide here. Let's jump into a few example problems where we're going to practice finding the inverse of a 2x2 matrix with that formula. The directions on this example are simply to find the inverse of the matrix. So I like to start kind of step 1 by finding the determinant of the matrix. And the reason I'm going to start with this is because if this determinant turns out to be 0, then I can stop and I don't have to finish the problem because the matrix is singular and it doesn't have an inverse. So I'm going to begin with that right there. And so if you remember to do the determinant, you multiply those two numbers, which is 6, minus, and you multiply these two numbers, which is 4, and the determinant is 2. So because that's not 0, we can proceed. And the second step is going to be to work through the formula for finding the inverse. And so the formula, so I want A inverse, which A to the -1 power is read as A inverse. I'm going to take 1 divided by the determinant that I found here, 2. So 1/2 times. Now the numbers on the main diagonal, I call it the main diagonal, the 3 and the 2, those are going to switch places. The numbers on this secondary diagonal are going to stay in the same place, but they're going to switch signs. So that 1's going to become negative and the 4 is going to become negative. And then we're going to finish this by simply distributing the 1/2 as a scalar. This is simply just a scalar product now. So I'm going to take that 1/2, I'm going to distribute it to every entry of this matrix. And so I'm going to end up with half of 2 is 1, half of -1 is -1/2, half of -4 is -2, and half of 3 is 3/2. It is very common in finding the inverse of a matrix that you're going to have some fractions in your matrix. And that's simply because we've got this fractional scalar right here that's going to distribute. And so that's very commonplace. So don't worry about that when it happens. In this next example, we want to find the inverse of matrix B. So again, I'm going to start by finding the determinant of matrix B. So I'm going to go 4 times 3 is 12, minus 6 times 2 is 12, and that equals 0. Because it equals 0, this matrix has no inverse. Okay, we could say that matrix B is singular. So that finishes the problem. We can't find the inverse if there isn't going to be an inverse. Next thing I want to talk about concerning inverse matrices is the identity matrix. Let's go over some properties about the identity matrix. Alright, so your identity matrix is going to be a square matrix. It's going to have 1s on the main diagonal and 0s in all other spots. And it's the matrix that you get when you find the product of a matrix and its inverse. So let me give you some examples of what the identity matrix is for some of the smaller square matrices. Alright, so you can see in these examples of a 2x2, 3x3, and 4x4 matrix, we have 1s right here on the main diagonal. And the main diagonal is the one I'm talking about when I start in the top left-hand corner and I go down through the matrix to the bottom right-hand corner. So there you see 1s on this diagonal coming straight down, and then 1s on this diagonal also coming down, top left to bottom right. So that's what the identity matrix is going to look like. 0s in every other spot within the matrix. Now this last bullet point, we're going to show an example problem next, that the identity matrix is what you get when you find the product of any matrix and that matrix's inverse. So let's see that in the next example problem. The directions on this problem are to determine if the two matrices are inverses. So if these two matrices are inverses, what we're looking for is that they're products. So if I do A times B, we're going to get I, which stands for the identity matrix. So let's go ahead and check that. Let's just set this up as a product. Alright, so I have my two matrices set side by side. They're multiplied together. Remember that when we multiply matrices back from section 2.2's video, we're going to take rows on this side, and then we're going to take columns on the other side. And I'll go ahead and do some scratch work down below as well. So I'm going to start with the first row, first column. I'm going to take 4 times 3/2, which is 6, plus 10 times -1/2, which is -5. That equals 1. Now I'm going to stay in the top row. I'm going to do the second column here. So I'm going to do 4 times negative 5 halves, which is negative 10, plus, and then 10 times 1 is 10. That's 0. I'm going to come down to the bottom row, and I'm going to do the first column. 2 times 3 halves is 3, plus 6 times negative half is negative 3. That's 0. And I'm going to stay in the bottom row and do the last column. So 2 times negative 5 halves is negative 5, plus, and then 6 times 1 is 6, and that's 1. Okay, so this matrix here is the identity matrix. So yes, A and B are inverses. Now, we have previously talked about in the 2.2 video, when we talked about matrix multiplication, we have said that when you multiply two matrices, that in general, right, that matrix multiplication is not commutative. So A times B is not the same as B times A. The exception to this is if the matrices are inverses. So not only is A times B equal to the identity matrix, but if they are inverses, B times A is also going to be the identity matrix. So this is kind of your special case where matrix multiplication is going to be commutative, but in all other circumstances it's not going to be so. So just this one case here. So if you're asked to do a problem like this, you can determine, maybe based on what numbers you see in the rows and the columns, how you want to set this up. If which matrix you want on the left and which matrix you want on the right, because it's not going to matter. You can do it either way. Finally, I want to touch on real quick how we can do matrices on our graphing calculator. So here I have a picture of a TI-84 Plus graphing calculator. It's the same one that I like to do my work on. And it's the standard. It's probably what you've got if you're watching at home. So first off, these calculators can do all the matrix operations that we have talked about so far in this chapter video series on matrices. I've just been showing you how to do it all by hand, but the calculator can do it, and it can do it much more efficient and quicker than we can by hand. So first off, where is the matrix button? So the matrix menu is actually the second button on the x to the negative 1 button. So it's on the left hand side about halfway down. I'll show you on my calculator here. I'll pull it up to the top here. So right there on that button that says x to the negative 1, there is a button above that says matrix. So that's the one that you're going to access. And when you hit that button, it pops out this screen that has a lot of different stuff on it. It's got names of matrices. So this is where the matrices are, where you have stored the matrices. It's got this middle tab here called math, and that's where you're going to find a lot of the special functions, different than your add, subtract, and multiply. But that's where you're going to find like determinant and things like that, kind of those extra things that aren't on the face of the calculator. And then it's got this edit tab, and the edit tab is where you are going to input the matrices into your calculator. So the last slide that I've got in the notes in this video, I just want to go over kind of how to put those matrices into the calculator and kind of how to output some simple functions with matrices. This last example slide, we've got 4 different matrices, and we are asked to do a variety of things, operations with those matrices. So the first thing we're going to do is we're going to do this all in the calculator. The first thing we need to do is we need to type in these matrices into the calculator here. So first thing I'm going to do is I'm going to go ahead and get into my matrix menu. So I'm going to walk you through this first one, and then we'll speed up the video as I put in the rest of them, okay? Access the matrix button. So you're going to hit the second button and then you're going to hit that x to the negative 1 button. It pulls you into that menu right there. Now there's nothing there. If there is something there, if you've got like a 2x2, 3x3 matrix, etc., it's okay. You can edit over them. So I'm going to go over to edit, using the arrow keys. I'm going to hit enter on that first matrix A. It's going to ask you for a size. So that matrix is a 2x2. So I'm hitting 2, enter, 2. And notice that it has adjusted the size of the matrix. And I'm just going to put the numbers in. So 4, enter, 1, enter, negative 3, and 7. Make sure that when you do the negative numbers that you are using the negative button and not the subtraction button. Okay, so that's matrix A. Now I'm going to hit my second matrix, and it's going to take me back to my matrix screen. I'm going to go over to edit, and I'm going to arrow down, so I'm going to hit the down arrow. I'm going to go into matrix 2 or B, and I'm going to edit that one. So what you need to do is just take a moment and put in matrix A, B, C, and D, and when all those matrices are in, we'll come back together and we'll work through these problems. Okay, so I've got all 4 matrices typed in. When I was finished, I hit second mode to quit and go back to my main computation screen. Now I want to type in these problems. So the first one is to do 4 times matrix A plus 7 times matrix B. So I'm going to type 4, and then I need matrix A. So I'm going to go to my matrix menu, and where matrix A is listed right here, I'm just going to select it. I can use my up and down arrows, select the matrix that I want. I'm going to hit enter, and it pulls that out to the main screen. So notice that right now it says, where are we at here? Hold on. It says 4 times matrix A. And now I want to add to that 7 times matrix B. So that's my first problem. I'm going to hit enter. It's going to do all the scalar products and the adding and subtracting for me. And we get the following solution. Now we can also do matrix products. Okay, so that's the whole row times column thing that I just did. So I want to do B times D. So I'm going to go into my matrix menu. I'm going to select B. I'm going to multiply. I'm going to go back into my matrix menu. I'm going to select matrix D. If it's possible, it'll give me an answer for it. And it did give me an answer for it. The answer is 47, 14. Next problem wants B inverse. Okay, so that's the new inverse stuff we just talked about in this video. So I'm going to go in and select matrix B. And now I need inverse. So the inverse key is the same key that we're doing to get the matrix. So right there, that x to the negative 1 key. I'm just not going to hit second in that key because I don't want the matrix. I just want that button itself. So I hit that, and notice it pulls up this negative 1 exponent above the B right there. So that's going to be my inverse. I hit enter. I get all these decimals. If I want to get rid of all those decimals and turn them into fractions, I can hit the math button right there, and the first one will convert to fractions. So I'm going to hit enter on that and enter on that, and it's going to change all those decimals into reduced fractions for me. So the inverse of matrix B is 1/22, 9/44, 3/22, and 5/44. Okay, finally, last example is asking for a determinant. We want the determinant of matrix C. This is a 3x3, so this is where we write the first 2 columns behind it, and we do all those diagonals. So we know the process. We've done that. We've practiced that. We can do that on the calculator as well. So to do that, I'm going to go into my matrix menu. So second matrix, I'm going to go over to math, and that first one right there, you can see it says DET, which is my determinant. So I'm going to select that. I'm going to go back into matrix. I'm going to pull out matrix C. Okay, so this is going to compute the determinant of matrix C, and it is -16. Okay, that's it for this video on matrix inverses, and also using the graphing calculator to compute all these operations with matrices. I hope you found this video helpful, and if you did, please support the channel by giving the video a thumbs up. If you have any comments or questions, please leave them below. And as always, I'll see you in the next video.